is, what does the natural logarithm relate to? What's its inverse? What do we use it to solve? Right, so if I write y equals e to the power of x, the inverse function of that is log to the base e of y equals x, yeah? All right. Log to the base e, however, is written as the natural log of y equals x. If we then write it as its own a function in its own right, it's the natural log of x equals y. Okay, got that? So the natural log of x is the inverse function of e to the power of x. Now, what do you know about inverse functions? I'm not going to do this again. All right? If I put x into a function of x, I get y out. If I put y into the inverse function of y, I get x out. Y is the range and x is the domain. If I treat the inverse, but I say, oh, it's x and it's the inverse function of x, and I get the y out, then what was the range becomes the domain. Okay, and what was the domain becomes the range. So what we could actually do is, if I don't know the domain and range of the natural log of x, I could look at, or do I know the domain and range of e to the power of x? And I'm kind of hoping you do, because it's not a hard one. Because all exponential functions, and I can look at those things on the wall that we did in the other room last year, an exponential function looks like that, yeah? Where does it cross? Because that's when x is 0, so it's e to the power of 0, which equals 1. Has it got an asymptote?
Yes.
Okay, all right. So of e to the power of x, what's the domain? X can be any real number. What can y be? The range. Y can be any real number, but y must be greater than 0. Therefore, we can use that information to say the natural log of x, the domain now is x can be any real number, but x has to be greater than 0. And the range, y can be any real number. You swap the two around. Okay? Packing up early. What I like. Best use of your time. And it's recorded.